Hello everyone, you're welcome to solve this nice algebra problem which is minus 5 raised to power x. This is equal to 5. So what is the value of x? To solve for the value of x here, we are going to apply two methods. That is, let's provide a solution here. Let's start with method 1. So under method 1, we are going to apply the aspect of natural logarithms, such that if you have the L, that is the natural log of a to base b equal to y, this implies that a is greater than 0, b is greater than 0, and that b is not equal to 1. Now, bearing these conditions in mind, we have minus 5 raised to power x. This is equal to 5. So we can express minus 5 raised to power x as minus 1 times 5 raised to power x. This is equal to 5. So in this case, we have that minus 1 times 5. This is in the form of a times b raised to power n, which we can express as a to the power of n times b to the power of n. Applying this exponent property, here we have minus 1 raised to power x times 5 to the power of x. This is equal to 5. To solve for the value of x here, we are going to apply the Euler's formula. Let's apply the Euler's formula identity. Let's use the Euler's identity, which is exponent e to the power of I pi plus 1. This is equal to 0. From this identity, we can make exponent e to the power of I pi to be the subject of the formula. So this means that this is equal to minus 1. So this implies that we can substitute where we have minus 1 here with exponent e to the power of I pi. So we have e to the power of I pi raised to power x times 5 to power x. This is equal to 5. To solve for x here, we introduce natural logarithm on both sides, so that here we have ln of e to the power of I pi x times 5 to power x. This is equal to ln of 5. So the next step from here, we have that ln of e to the power of I pi x times 5 to power x. This is in the form of ln of a times b, which we can express as ln of a plus ln of b. Applying this natural logarithm property, then this implies that we have ln of e to the power of I pi x, then plus ln of 5 to the power of x. This is equal to natural, that is ln of 5. Now, the next step from here, you find that ln of e to the power of I pi x and ln of 5 to power x, this is in the form of ln of a to power n, which we can express as n ln of a. So let's apply this property, this power rule property. Now applying this power rule property from here, this implies that we have I pi x ln of exponent e, then plus x ln of 5. This is equal to ln of 5. So from here, since x is common here, we can factor out x so that we'll have x into the parentheses. We have I pi ln of e, then plus ln of 5, close the parentheses here. This is equal to ln of 5. Now, we have that ln of e to base a, this is the same thing as 1. Now, ln of a to base a, this is the same thing as 1. So here we have x into the parentheses. This is I pi plus ln of 5, close the parentheses. This is equal to ln of 5. So the next step from here, let's divide both signs by I pi plus ln of 5. Okay, so here we have I pi plus ln of 5. So let's simplify here. And this implies that x is equal to ln of 5 divided by I pi plus ln of 5. So this is the solution. This is the value of x by applying method 1. So this is the solution by applying method 1. So let's proceed to method 2. That is method 2. Now, in method 2, we are going to use a common logarithm properties. That is common logarithm properties. Now, remember we have minus 5 raised to power x. This is equal to 5. We can express minus 5 to power x as minus 1 times 5 raised to power x. This is equal to minus 1 times 5 raised to power x. This is in the form of a times b raised to power n, which you can express as a to the power of n times b to the power of n. So here we have minus 1 raised to power x times 5 to power x. This is equal to 5. So the next step from here, we can express minus 1. This is the same thing as I squared. So let's substitute minus 1 with I squared. So here we have I squared raised to power x multiplied by 5 to the power of x. This is equal to 5. Now, you find that to solve for x here, we introduce that is logarithm on both sides, so that now here we have log. This is the same thing as log I squared raised to power x times 5 to power x. This is equal to log 5. Then you find that log I squared to power x, log I squared to power x times 5 to power x. This is in the form of log a times b, which you can express as log a plus log b. Applying this logarithm property, then here we have log I squared to power x, then plus log 5 to power x. This is equal to log 5. Then you find that log I squared to power x and log 5 to power x, this is in the form of log a to the power of n, which we can express as n log a. Applying this power rule property of logarithm, then log I squared to power x becomes x log I squared, then plus, here we have log 5 to power x becomes x log 5. This is equal to 5. But now since x is common here, we can factor out x so that we'll have x into the parentheses. This is log I squared plus log 5 close the parentheses. This is equal to log 5. Sorry, here this is log 5. That is log 5. Now, from here, we have that log I to power 2. Applying this power rule property, this becomes x into the parentheses. This is 2 log I plus log 5 cross the parentheses. This is equal to log 5. So let's divide both signs from here by 2 log I plus log 5, and also here divided by 2 log I plus log 5. So let's simplify here. so that x is equal to log 5 divided by, this is log 5 plus 2 log I. So this is the value of x by applying method 2. Okay, so kindly follow the steps, like this video, and subscribe. If you have alternative formulas, kindly showcase them in the comment section. You can write down in the comment section. Thank you for watching.